We are solving now question number 11 for A2 levels of P3 for the topic of differentiation. The question statement is the diagram shows a curve with the parametric equations x is equal to sine t plus cos t and y equal to sine cube t plus cos cube t, where t lies between pi by 4 to 5 pi by 4. Show that dy by dx is equal to minus 3 sine t cos t. And the second part of this is find the gradient of the curve at the origin. And the third part of this, find the value of t for which the gradient of the curve is 1, giving your answer correct to the two significant figures. So here we are going to find out dy by dx. Because these two equations are in form of t, so that is known as to be called the parametric equations. So we will, by using the parametric equations, we can find out dy by dx is equal to dy upon dt over dx upon dt. That thing is equal to, for this, it is power there. So power will become the coefficient. This will become 3 sine square t, and without power, sine t derivative is cos of t plus cos 2t. This will become 3 cos square t, and then whole power, the derivative of cos of t is minus sine of t. And dx by dt is sine t derivative is cos of t, and cos derivative is minus sine of t. Here, minus 3 sine square t cos of t minus 3 cos square t into sine t divided by cos of t minus sine of t. So dy by dx is equal to 3 sine t cos t is common. It is left there sine t minus cos t divided by cos of t minus sine of t. It is sine t minus cos t, and this one is cos t minus sine t. So we can take minus as common. 3 sine t into cos t, and this will become cos t minus sine t divided by cos of t minus sine of t. This and this they are going to cancel out. So dy by dx is equal to minus 3 sine t cos t. This is the answer to this first part, that find dy by dx for this parametric equation. Now for the second part, find gradient, that is dy by dx at region, that is 0, 0, 0. So first, for this origin 0, 0, we know either the x coordinate or the y coordinate, they are equal to zeros. So if we use 0 for x, let's say x is equal to sine t plus cos t. You put x equal to 0, it is sine t plus cos t, or sine t is equal to minus cos t, dividing it on both sides by cos of t. So this thing will become tangent of t equal to minus 1. Since tangent of t equal to -1, the minus indicate that the tangent is negative in the third and the fourth quadrant. So let tangent of t equal to 1, then t is equal to tangent inverse of 1, and that is equal to pi by 4. For the second quadrant, t equal to pi minus pi by 4, and for this quadrant, 2 pi minus pi by 4. So this will become 3 pi by 4, and this will become 7 pi by 4. That is the value of t here. But since t value is lying between pi by 4 to 5 pi by 4, so this value is going to exceed. So this will not be taken. So t value is there. That is 3 pi by 4. And now we will calculate the gradient at this point. dy by dx is equal to -3 sin t into cos t. So that is -3 sine of 3 pi by 4 into cos of 3 pi by 4. That is -3. Sine of 3 pi by 4 is 1 over root 2. And cos 3 pi by 2 is -1 over root 2. And that thing will become minus positive, and root 2 into root 2 is 2. So gradient at the origin is equal to 3 by 2 there. And in the last part, find the value of t for which the gradient of the curve is 1. So, as we already know that the gradient of this curve is -3 sin t cos t. And that thing is equal to 1. So, sin t into cos t is equal to -1 over 3. If you multiply both sides by 2, 2 sin t cos t is equal to -2 by 3. But we know that sin 2 sin t cos t is equal to sin 2t. So this is equal to sin of 2t is equal to 2 by 3. This minus again indicates that sign is negative in the third and the fourth quadrant, and there are two cycles, so there are four values for this part there. Let's say it is A, it is B, it is C, and this one is D. So 2t is equal to A, B, C, and D, where A value is the third quadrant, so it should be equal to 2t is equal to sine inverse of 2 by 3. So 2t is equal to 0.3t. So it is in the second and the third and the fourth quadrant. So 2t is equal to A, B, C, and D, where A value is equal to pi plus 0.73. B value is 2 by minus 0.73. C value is A plus 2 pi, and D value is T plus 2 pi. So 2t is basically equal to A, B, C, D, and when you divide it by 2, it should be A by 2, B by 2, C by 2, and D by 2. So these are the values of t, but t is in between. They have mentioned that it is lying between pi by 4 to 5 pi by 4. So values which occurs in this range, then the answers for the value of t there, which will be so the values of this C and D are going to be rejected out because they are out of the range. So t value is equal to A, that is 5 plus 0.73 divided by 2, and B value is 2 into 3.142 minus 0.73 divided by 2. So the t value will be equal to 1.9, and so t value will be equal to 1.9 and 2.8 are the two specific values which we got from this calculation, which lies between pi by 4 to 5 pi by 4 for this question statement there. So this is the complete solution of this problem, where we have used the differentiation for the implicit functions and then we have calculated the gradient at the 2 points. But remember one thing, that sine 2, the third part, we can make it sine of 2t, which is equal to minus 2 by 3, and that going to lie in the third and the fourth quadrant. And because C and D part are not in the range of this, so only the values of A and B will be calculated, which we have used in this part there.